June 5th, 2026. NASA broke the sound barrier. And for the first time in history, nobody heard it. A supersonic jet that nobody hears. That's like a silent chainsaw. That's like a whisper at a heavy metal concert. That right there is the single most important aviation engineering story of the decade. 1976. Concorde enters commercial service. It looks like a fighter jet that went to finishing school. It's gorgeous, it's fast. London to New York in 3.5 hours, faster than most people can sit through a Christopher Nolan movie without a bathroom break. Think about that. You board at Heathrow, sip Dom Perignon, watch The Dark Knight on a tiny screen, blink twice, and suddenly you're in New York, deplaning, and some guy in a yellow cab is already yelling at you about the fare. Concorde was fast, but speed doesn't pay the bills. It operated for 27 years and barely made a profit. In fact, British Airways and Air France kept it alive mostly for national pride. Here's why. It was banned over land. You couldn't fly LA to New York. You couldn't fly Tokyo to London. You could only fly over water. Why? 110 decibels. That's the sonic boom, a rock concert in your living room. Every single time it passed overhead. A sonic boom isn't a one-time crack. It's a continuous carpet of compressed air dragged behind the plane for hundreds of miles. If Concorde flew over Kansas, it would wake up everyone in a 40-mile wide swath. So Concorde was limited to transatlantic routes. How many people need to cross the Atlantic in 3 hours at 5 times the price? Not enough. When Air France Flight 4590 crashed in 2000, the public turned, 9/11 finished the job. By 2003, Concorde was a museum piece, and for 20 years, supersonic passenger travel was dead. Not because we couldn't go fast, but because we couldn't go fast quietly. That's the problem NASA set out to solve. And to understand their solution, we need to understand the physics of the boom. Let's get physical. When an airplane flies, it pushes air out of the way. Think of a boat moving through water. At subsonic speeds, those ripples travel ahead of the plane. The plane is polite. It announces its arrival. At supersonic speeds, the plane outruns its own sound waves. Ripples pile up, compress, merge into a single massive shockwave, shaped like a cone. Mathematically, it's a Mach cone. The half angle is arcsin 1 minor. At Mach 1.1, that's about 65 degrees. This cone follows the plane everywhere. It's a continuous wake of compressed air. The plane drags it like a drunk dragging a trash can down the street, every single mile. When that cone hits the ground, the pressure signature looks like the letter N2 sharp pressure jumps. First no shock, then gradual pressure drop. Then tail shock, 2 bangs, one after the other. A 110 decibels. A rock concert is 110. A chainsaw at ear level is 100. Concorde was louder than a chainsaw, and it also served caviar. The boom carpet is about 40 miles wide. If Concorde flew over you, you didn't just hear it. You felt it. Windows shook. Dishes rattled. Pets panicked. Here's the X-59 Quesst. If Concorde was a fighter jet in a tuxedo, this thing is a geometry experiment that accidentally learned to fly. Look at the nose, 30 feet long, 1/3 of the entire aircraft. Why? Because NASA is fighting compressible fluid dynamics with geometry. Here's the aerodynamic principle. You can't eliminate the shock wave, but you can change how that shock forms. You can spread the pressure, rise over time. The long nose creates pre-compression. As the needle nose slices through air, it gently raises pressure ahead of the main shock. The air has time to adjust. But the nose is just the start. The engine is mounted on top. Why? Because the underside reflects shock waves downward. Top mount lets shock waves expand into free air. The engine itself is a General Electric F444 GE100. Dry thrust about 22,000 pounds force. But the inlet is custom variable geometry ramps for each Mach number. Then there's the T-tail. It sits above the engine exhaust, breaking up the nozzle's complex shock pattern. Every geometry choice on this aircraft is optimized for one thing, making the pressure signature look like a gentle hill instead of a brick wall. This is inverse design engineering. You don't design the plane for looks, or speed, or payload. You design it for the pressure signature. Then you figure out how to make it fly. And that's why it looks so weird. It's not designed to be beautiful. It's designed to be quiet. Here's the trade-off. That beautiful 30-foot nose that kills the boom, it also kills the pilot's forward visibility. No forward-facing window. Zero. The pilot sits about halfway down the fuselage. He literally cannot see where he's going. This isn't a submarine. There's no periscope. NASA calls it the External Vision System, XVS, for 4K cameras mounted on the fuselage, plus synthetic vision database. Two sources fused into one image on a 4K screen. Here's the engineering nightmare: latency. If the camera feed lags by even 50 milliseconds, the pilot's perception is off. At 1,000 feet per minute descent, a 50 millisecond delay means half a foot behind reality. The human brain processes visual input in about 80 to 100 milliseconds. The XVS system is actually faster than your own eyes. The computer sees better than the pilot. The FAA has never certified a primary vision system without direct forward windows. Glass is simple. Glass doesn't have software bugs. Glass doesn't need cybersecurity patches. The architecture has two completely independent camera paths, each with its own lens, sensor, processor, power supply. Cross-check against each other. If both fail, synthetic vision takes over using inertial and GPS data. But that's a degraded mode. NASA has to certify every single failure scenario. June 5th, 2026. X-59 takes off from Edwards Air Force Base. Same base where Chuck Yeager broke the sound barrier in 1947 in the Bell X-1. The old generation and the new separated by 80 years. Test pilot Jim Clue climbs to 43,400 feet, pushes the throttle. First supersonic flight, Mach 1.1 primed 713 miles per hour. The flight lasted 81 minutes. The supersonic portion, less than 10 minutes. Most of the time was envelope expansion, gradually pushing the aircraft to higher speeds and altitudes. Here's what they measured. Structural integrity passed, flutter margins within limits, angle of attack stability nominal, control surface effectiveness stable. Let me talk about flutter. It's a self-excited aeroelastic vibration. On an aircraft, if the wing's natural frequency aligns with aerodynamic forces, oscillations amplify. In seconds, divergent oscillation, catastrophic. X-59's slender geometry, LD ratio over 25, is actually more prone to flutter. So the composite layup was tailored to raise the flutter speed index above Mach 1.6. Here's the big catch. They didn't actually measure the sonic boom. Why? The F-15 chase plane, it produces a sonic boom of about 1.5 psf. The X-59's target is under 0.5 psf. The F-15 completely masked it. NASA couldn't hear the X-59 because their measuring device was screaming in their ear. The good news, next tests won't have a chase plane. They'll use ground-based microphone arrays, 40 to 50 sensors in a precise grid. Direct measurement of the N-wave. No mask, no interference, pure X-59 signature. Next up, Mach 1.4 at 55,000 feet. Then Mach 1.6 at 60,000 feet, twice the altitude and speed of a commercial airliner, the limit of the envelope. After that, community overflight tests. X-59 flies over actual towns. NASA asks residents, "Did you hear something?" On a scale of 1 to 10, how annoying was it? That subjective data, psychacoustic measurement, is what regulators care about. Not decibels. Perceived loudness. The X-59 targets 75 PLDB. Concorde was over 100. NASA will hand this data to the FAA and ICAO. FAA will revise FAR Part 91.817, the current ban on civil supersonic over land. ICAO will create a new chapter in Annex 16. Current law is zero tolerance. The proposed replacement is performance-based, a maximum overpressure limit of 0.5 psf. If your aircraft meets that, you can fly over land. Simple, scalable. And that's when the market opens. Boom. Supersonic Overture, Mach 1.7, 64 passengers. Spike S5112. They're all waiting for NASA to finish the paperwork. Concorde was the rock star. Loud. Fast. Sexy. Unsustainable. X-59 is the engineer. Quiet. Weird looking. Boring to the casual observer, but designed to last. Long run, the engineer always wins. Mr. Chatterboss out. Fly safe. Fly quiet. And for the love of Mach, stop calling it Son of Concorde. It's not. Concorde was the past. This is the future.